The transverse section here of a nerve fascicle is much the same as the one you have just seen, except that it's been stained with hematoxylin and eosin. Most section nerves that you'll be seeing from now on probably will be stained with hematoxylin and eosin, so it's useful to examine this section even if it's a bit harder to interpret than a trichrome stained section. Let me try and point out each of the structures I showed you in the cross section with the Masson stain. One thing that you may already notice is that the nerve fibers are not exactly straight, as you can see transverse and oblique profiles indicating they follow a rather tortuous path. Here is the epineurium and the perineurial sheath, endoneurium with capillaries and fibroblasts, myelinated axons, and there are some very small clusters of non-myelinated axons and Schwann cell nuclei. The vagus nerve, shown here, consists almost entirely of small unmyelinated fibers. The axons themselves look like hollow tubes. If you look here, for instance, where they have been cut as transversely as possible. The section shows plenty of Schwann cell nuclei and nicely demonstrates blood vessels and connective tissue layers. One thing to mention is that there is little elastica in the epineurium. Nerves are extremely tough to break and not elastic at all. This transverse section of a peripheral nerve has been stained with silver. Although the axons are somewhat shriveled, this sort of staining nicely complements the more conventional ones. Silver specifically stains the axons and nuclei. Cytoplasm and cell membranes, being mainly myelin, are unstained. However, if you look very carefully, you can see ghosts of the outer boundary of some myelin sheaths in cross-section. Silver stains are particularly useful for demonstrating small, unmyelinated fibers, which often run in clusters. First, let me point out myelinated axons. Myelinated axons are separated from each other by a substantial space. Let's not worry too much about nuclei of Schwann cells here. The unmyelinated fibers really stand out. They appear as small dots in clusters. Now let's go back and look at the longitudinal section through the peripheral nerve I first showed you. It contains the same structures as seen in the transverse section and gives you a chance to figure out what these elongate structures look like from a different perspective. The ovoid nuclei within the bundles of axons belong to Schwann cells. Pick out the myelinated axons as lumpy orange lines surrounded by cobwebby layers of myelin protein. Once you see them, it's easy to pick out a node of Ronvier. Here's one here, and also here. You will not be able to pick out small unmyelinated axons in this longitudinal section because the section is much thicker than the axons, so other tissue above and below masks them. You can, however, find seams of endoneurial loose connective tissue with some very elongated fibroblast nuclei and perineurial sheaths of flattened Schwann cells just under the more dense connective tissue of the epineurium.